Okay guys, coming at you with an epic video about math. And by epic, I mean never ending this time. Okay, we do have a bit of a long video here, and it's about the triangle bisector theorem. We're going to talk about the triangle bisector theorem but we're going to have 4 examples, and they're going to require quite a lot of explanation. So let's take a look. Okay. What is the triangle bisector theorem? A theorem, let's not forget, a theorem is a theory that's always proven true. And that means that the triangle bisector theorem always works when you can apply it. If a segment bisects an angle of a triangle, then it divides the opposite side proportionally to the other 2 sides. Bisect means to cut in half. So when an angle in a triangle is cut in half, it's creating 2 similar triangles. That's what's happening. And this guy did not learn his lesson. Alright, let's take a look. First, this is what the questions typically look like. It just says solve for x. There's very little information here. But I take a minute and I notice that I have 2 congruent angles. Those red marks there, those are angle congruency marks. They're telling me that this and this angle are the same. As a result of that, I can conclude that this line is cutting this angle in half, or it's being bisected. So that means I could apply the triangle bisector theorem. So that means I have 2 triangles here now that are similar. And what I'm going to do is I'm going to label this one 1 and this one 2 for your purposes. You don't have to label them. I just want to make things a little bit clear for you guys. I know that I can set up a proportion. Well, I take a look back for a second, or I step back away, and I notice that 21 over 24 is reducible. So that's the direction I'm going to go in. And just like all the similarity proportions, what I do on one side of the equal sign dictates what I'm going to do on the next. So I'm going to go from triangle 1 to triangle 2, 21 to 24. So that means I have to go from x to 30 minus x. Now I'm going to reduce those. I'm going to need my calculator. So 21 over 24 reduces to 7 over 8. Now you're wondering, wait a minute. If he's using his calculator to reduce, why is this multiply in the first place? It is of my opinion, my humble opinion, which is always right, but it's still my opinion, that you're less likely to make a mistake when you have smaller numbers. I prefer to multiply 30 times 7 as opposed to 30 times 21 and deal with that 610 floating around. It's just going to be a little bit more difficult. So now, I have 8x, because 8 is going to multiply x. I'm cross-multiplying, so 8 is going to go to x. Then 30 minus x is going to go to 7. So I have 8x equals 7 times 30 minus x. Then I'm going to distribute the 7 to both the 30 and the x, or negative x. So that's going to give me 8x is going to equal 210 minus 7x. Now I'm going to add the 7x, and I'm going to get 15x equals 210. Then I'm going to divide by 15, and x is going to equal, let's see what that is, 210 divided by 15 gives me 14. So x equals 14. And that's how we do that. Okay, next example. Okay, this one. This one's a little bit more complicated now. It says solve for x again, right? And now I have kind of a little bit more going on here. Well, again, I notice my congruent triangles. Let's try that again. Congruent angles. So since these two angles are congruent, I know this line is bisecting those angles, which is creating two similar triangles. So again, I'm going to label that 1 and 2. And a reminder, I am doing that for the video. You don't have to do that. Now I notice that triangle 1 has these two parts here. So that's good, right? But triangle 2 doesn't. But what they do give me is this length of 20 units here, which is the sides of 1 and 2 added together. So what I want to do is get this length here to this side of triangle 2. I could subtract 6 from 20, or 20 minus 6 to get that. So that's what I'm going to do. 20 minus 6, and that's going to give me 14. So I'm going to get 14 here. Now, since I know that I have a bisected angle, I know I could apply the triangle bisector theorem. And that's what I'm going to do. So I'm going to set up a proportion. And I'm going to stop and look for a second. I'm going to notice that 14 and 21 reduce really, really nicely. So in triangle 2, I'm going to go 14 to 21. 14 to 21. So I went from this guy at the bottom up. So this guy at the bottom up on triangle 2. So I have to do that on this one. So I have to go from the bottom up. And I did that just so you guys could see how the consistency matters. But finding reducible parts does make the problem easier. You don't have to reduce. You don't have to reduce, and it doesn't always help. But in this case, it's going to. So you want to pause for a second and try to make the problem easier for yourself. So this reduces to 2 over 3. Look how nice that is. This went from a rather intimidating problem to a much easier problem to look at, in my opinion, because the numbers are smaller. Now I'm going to cross multiply, so that 3 is going to multiply the 6, and it's going to give me 18. And the 4x minus 3 is going to multiply the 2, so I'm going to get 2, and it's going to distribute to the 4x minus 3. And now I'm going to distribute that 2 because I'm multiplying that whole expression times 2. So we got to make sure the entire expression gets to 2. Now I'm going to undo the subtraction by adding 6. I'm going to get 24 equals 8x. So I'm going to undo that multiplication by dividing. So x equals 3. Done. Alright, next example, which is going to be this one. I kind of didn't organize my whiteboards that well this time. Alright, same gig here. This time I pre-numbered them 1 and 2. Okay, I notice that my angles are congruent. So that means that this line is bisecting the entire angle. So that means that these triangles are similar. I could apply the triangle bisector theorem. So from there, I'm going to try to figure that out. Now what I notice again is that this part here is missing. But I can subtract this from this expression because 4x plus 1, the expression 4x plus 1, it represents the sides of 1 and 2 added together. Okay, so I'm going to say 4x plus 1 minus 21. That's the same thing, the same logic we applied here. I had 6 and I subtracted it from 20. I have 21, I'm subtracting it from 4x plus 1. Now here I have a 3-term expression now, but only 2 of the terms are going to add together. 4x, see there's an x here, is not going to add to any of these because there's no x present. So that's what I need to do. I need to add these 2 together. So I have 4x minus 20. Okay. The reason why that happened is because I combined these like terms. So it's basically like looking at 1 plus negative 21, and I get that. So this is 4x minus 20. Okay, now I want to set up my proportion. All right, well, again, I look at 28 and 21, and I notice that they're reducible. 28, 21. So as a result, if I went from 28 to 21, I have to go from 16 to 4x minus 20. I'm going to reduce that really nicely by 7, right? It's making my numbers a whole lot smaller. 4 over 3, that looks like. 16, 4x minus 20. Now I'm going to cross multiply. This guy's going to multiply the 16, and that's going to give me 48. Then the 4x minus 20, that whole expression is going to multiply the 4. So I'm going to have to distribute because the entire expression needs to get that 4. So I'm going to distribute the 4. I'm going to get 16x minus 80 equals 48. Then I add 80. And that's going to give me 128, I'm pretty sure. I'm going to double check that. So 40. Ooh, almost. See how easy it is to type on the calculator? 40 plus 80 gives me 128. Good. Which is going to equal 16x. Then I got to undo that multiplication. So I'm going to divide. So I'm going to divide by 16, and that's going to give me 8. So x equals 8. Okay, next and last example. So I'm going to keep those two whiteboards handy so we can see this, and let's not drop that. There we go. Okay, so I'm back at this again. It says solve for x. It gives me my congruent angles. So that brings me to the conclusion that this line is bisecting this whole angle here. So that tells me I can use the triangle bisector theorem. So now I'm going to look to set up a proportion. Well, what I notice is that triangle 1 has its parts, but triangle 2 doesn't. It's missing this. And just like the previous examples, so let's review that real quick. On this one, I did 20 minus 6 to get 14. On this one, I did 21 minus 4x plus 1 to get 20. On this one, I'm going to have to do 20 minus 2x minus 12. And there's some minor details there. So understand what I'm doing. I am subtracting this entire expression from that 20. So I'm going to say 20 minus 2x minus 12. But I'm subtracting that entire expression, so I have to put parentheses around it. Now, what I have to do is I have to distribute this negative. So what I want you guys to see is, and you don't have to rewrite this each time, but if it helps you, you should, is I'm basically kind of distributing a -1 to everything. I have to do that because just like when we cross multiplied, I have to make sure that negative gets to everything. So I'm going to distribute this to both of those terms. So now I'm going to get 20 minus 2x plus 12. Then I'm going to look for like terms. Well, the 2x has no like terms because the other two terms do not have x's in them. But I can combine these two. So I can combine 32 minus 2x. If you choose to, and I'm just going to mark this down so you guys can get exposed to the algebra, or the arithmetic, I should say, I could also write this as 2x negative 2x plus 32. However you wish to handle it. I'm going to use this one. So this is 32 minus 2x. And hopefully I didn't make any mistakes there. So now, I'm going to set up my proportion. Well, once again, I step back and I notice that 9 over 21 reduces nicely. Again, you don't have to reduce, but I find that to be a whole lot easier to handle. So 9 over 21, 9 over 21, so I'm going to go 2x minus 12 to 32 minus 2x, which is the side we created. I'm going to reduce that 3 over 7. It's not perfect, but it helps just a little. So now I'm going to cross multiply. So this expression, 32 minus 2x, is going to go to 3. And then 7 is going to go to that. So I have 7, 2x minus 12 equals 3 times 32 minus 2x. So just to recap, when I did this, I had to make sure that this negative or the subtraction sign went to both terms. That's like what's going on here. It's just another form of distribution. You just don't want to forget to do it because you'll get the whole problem wrong as a result. Now, I'm going to distribute this. So 7 times 2 is 14x. 7 times 12 is 84. Right? I'm going to double check that because I, as some of you may know, turns out I am a genius. Now, from there, I'm going to multiply 3 times 32. So that's 96. Let me double check that one. 3 times 32, 96. And then that's negative 6x. Okay, let's move some stuff around. I want to undo some subtractions. So I'm going to undo the negative 6x, make that a positive 6x, and add it to the 14. So that's going to give me 20x. I want to try to keep my x's positive. That is honestly just a preference. So that crosses out. Then I'm going to add 84 to the negative 84 to give me 0 there. And I'm going to add 84 to the 96. So 84 plus 96 is 180. Then I'm going to undo this multiplication here. So I'm going to divide by 20. So x equals 9. And that's how we do that. Alright guys, I know it was a bit of a long video. There was a lot of details in there. Hopefully you guys found this video about the triangle bisector theorem helpful.